Welcome to the Nokia SR Linux Learning Essentials video series, brought to you by the Nokia Data Center Fabric Certification Program. This video explains how to configure an SR Linux router as a gNMI server with a TLS profile. The gRPC Network Management Interface is a gRPC-based protocol that is used to configure and retrieve data from network devices. SR Linux supports the gNMI commands: get to retrieve a configuration item, set to modify a configuration item, subscribe for subscribing to telemetry data, and capabilities to exchange the set of gNMI capabilities. A transport layer security (TLS) profile is required to establish a secure and authenticated HTTP connection between the gNMI client and gNMI server. The TLS profile of a device includes the certificate authority or CA's public certificate, the device's certificate signed by the CA, and the device's private key. An SR Linux router can be configured as a gNMI server supporting multiple gNMI clients. Once a secure tunnel has been set up between the gNMI client and the gNMI server, messages can be securely exchanged. The SR Linux TLS profile comprises 3 files with the Privacy Enhanced Mail or PEM extension. The Linux host directory TLS contains the TLS profiles for the gNMI server, in other words, the Leaf1 router, and the gNMI client, in other words, the Linux host. On the Linux host, run the openSSL command for the leaf1.pm file to verify Leaf1's certificate signed by the CA. Looking at the certificate, we can see that the certificate will expire after the end date. Leaf1's public key is embedded in the certificate for decrypting message encrypted by Leaf1's private key. The subject alternative name indicates that Leaf1 can be accessed via the IP address 172.20.20.101. The device certificate is digitally signed by the CA using its private key for device authentication. Then run the cat leaf1-key.pem command to display the private key of Leaf1 for encrypting and signing messages. Devices with Leaf1's public key can decrypt and verify that the message is from Leaf1. And finally, run the cat root-ca.pem command. This is the public certificate of the CA, and it is used to verify whether or not a device's certificate is signed by the CA. For mutual client and server authentication, the gNMI client needs a similar set of TLS profile. The generation of the TLS profiles using tools such as OpenSSL is beyond the scope of this video. We have just examined Leaf1's TLS profile files. Let us configure the SR Linux router Leaf1 as a gNMI server that supports secure message exchange with the Linux host. Log into the Leaf1 SR Linux router. First, create a TLS server profile called lab. Configure the profile by copying the content of Leaf1's TLS profile files stored at the Linux host. Switch to the Linux host. Copy the Leaf1 private key in the leaf1-key.pem file and paste it into the key parameter on Leaf1. Switch to the Linux host. Copy the Leaf1 certificate in the leaf1.pem file and paste it into the certificate parameter on Leaf1. Switch to the Linux host. Copy the CA public certificate in the root-ca.pem file and paste it into the trust anchor parameter on Leaf1. Set authenticate client to true for mutual authentication. Then commit the configuration. As a second step, create a gRPC server on Leaf1 and name it gNMI server. Set the admin state to enable. Use the TLS profile lab for the server. Activate the server in the management network instance and set the port to 57400. Configure the server to support the gNMI service. And finally, accept from all sources by setting the source address to 0.0.0.0. Use the info command to verify your configuration and then commit the changes. Let us now verify our configuration. The Linux host has a gNMI command line client called gNMIC. Let us use gNMIC to send a GET request to retrieve the system hostname of Leaf1 at 172.20.20.101. The files of the client's TLS profile are provided in the command for a mutual authentication. The Leaf1 router replies to the gNMI's GET request with a GET response indicating that its hostname is Leaf1. That's it for SR Linux, gNMI, and TLS profiles. Thanks for watching, and be sure to explore the rest of this video series to learn more. And when you're ready to practice what you've learned, my DCF Learning Labs provides comprehensive exercises with step-by-step instructions and solutions, all in one simple browser-based application.